So let's understand the handover in phases. So there are four phases for a mobile WiMAX handovers, hard handovers specifically. The first phase is called the scanning phase, and after that mobile station does an handover initiation phase, and then handover preparation, and then handover execution. The step one of an handover phases is called scanning, and in this step the mobile station negotiates scanning period with its serving base station to perform measurements of the radio link quality with each neighboring base station. Once the handover conditions are reached or it crosses to a certain threshold, the handover initiation period starts. And in the step 2, which is called handover initiation, mobile station initiates the handover. In the handover preparation phase, which is called step 3, the network selects the target base station and reserves resources for the mobile station in the target base station and provides the mobile station with selected target base station to start the handover execution. And in the handover execution, mobile station performs network re-entry at the target base station, and services resume at the target base station. And during handover execution to a target base station, whatever data which were scheduled to go to the mobile station would be buffered in the ASN gateway, and once the handover is completed, the data would be forwarded to the mobile stations. Okay, so let's understand the first step of the handover, which is called scanning. Scanning consists in listening to neighbor base stations downlink frame in order to estimate the radio link quality between the mobile station and the neighboring base station. In addition, the serving base station provides the mobile station with the criteria to be used to include a neighbor base station in the list of the possible target base stations for handover. So the mobile station does a simple logic. If the CINR of the neighboring base station is greater than the CNR of the serving base station plus the margin, the hysteresis and protection margins, then add neighbor base station to the list of target base station. So whenever a mobile station sees a neighboring base station CNR is greater than CNR of the serving base station in the advertisement messages, it adds the neighbor base station to the list of target base stations for the handover. In the next phase, which is called the handover initiation phase, there are two criteria which will be used to do a handover. One of them is called either based on CNR or based on the RSSI. So if the RSSI or the CNR between the mobile station and the serving base station is below a given threshold, then the mobile station initiates a handover. So mobile station has the simple logic. If the CNR of the serving base station or RSSI of the serving base station is less than threshold defined for the handover, then initiate the handover. This is the step number 2. So for example, if the threshold defined as CNR 3 or RSSI minus 90, so the mobile stations wherever reaches to a CNR of 3 or RSSI of 90 would initiate and hand over to one of the strongest CNR candidate, which is listed in its table, neighbor base station table. In the step number 3, once it is identified, once the mobile station has identified its target base station, it will send and hand over request message to the serving base station, and the message goes in mobility message, and once the request is received by the serving base station, it initiates and handover pre-notification to ASN gateway, and ASN gateway in turn does a series of message requests for an handover preparation between target base station and in itself. Once there is a response from the target base station that it has necessary resources to take this handover, ASN gateway gives an instruction to the serving base station for an handover execution, and the serving base station gives an response back to a mobile station for an handover confirmation. And once the handover is confirmed, the mobile stations switches to a target base station. This is the fourth step, and once it switches to a target base station, it again starts the procedure that were highlighted in the network entry connection slides. So mobile station will again get the preamble and thus get the downlink map, uplink map, DCD, UCD, and then does an synchronization or ranging, fast ranging, and then does an capability negotiation of an SBC message, and then does an network entry to the target base station. Now, now the whole procedure between Phi and MAC and data reconnection might take between 50 to 80 milliseconds. So uh, the mobile station during the handover phase between the serving base station to target base station has a disruption time of 50 to 80 millisecond, and during this period, if any data which is destined for mobile station would be either saved in ASN gateway or in the home agent. So depends on what kind of architecture is being used. So in nutshell, WiMAX handovers are defined in four phases, and the phase one is the scanning phase, and the phase second is the handover initiation phase, and then the phase three is the handover preparation phase, and phase four is the handover execution phase. Oh, we are on slide number 22, and in this particular slide, uh, mobile WiMAX operations in different modes is presented. So mobile WiMAX supports um, active, sleeping, and listening modes. So in an active mode, normally mobile station transmits or receives data. In this mode, the mobile station may request for base station to enter sleep mode or save the power, and sleep mode start frame is indicated in active period. In the next mode, which is called sleep mode, mobile station sleeps for an integer time, or and this is also called a sleep interval. No mobile station transmits or receives data during this intervals when a mobile station is in sleep mode. And power saving classes supports flexible methods to start wake up of the device in an agreeable time. In listening mode, mobile station listens for an integer number of frames called listening interval, and paging detected in this interval. And if data traffic is weighted, then it has to be indicated in the listening mode. So there are, in nutshell, three types of modes in WiMAX. One of them is called active, the second is called sleep, and the last is called idle or listening mode. So let's go deep and understand WiMAX ideal modes. Both sleep and ideal mode are used for power saving. Benefits of ideal mode and sleep modes are mostly for network, and the network benefits the base station delivers the benefit by eliminating air interface and the network handover traffic from essentially inactive mobile stations. Mobile stations activity is limited to scanning at discrete intervals during the idle mode, and paging is used to trigger the network re-entry of the idle mode. So essentially, uh, in idle mode, the operation is as follows. And mobile station does not maintain any connection and active states with any base station when it is in idle mode. So, and actually the mobile station deregisters from the base station when it is in idle mode, and mobile station periodically wakes up to listen the paging messages to see if there is a data that is intended for that particular mobile. When a call arrives for an ideal mode mobile station, the network tries to page it, and to page an ideal mode mobile station, the network maintains its location information at the granularity of an paging area. Now, group of base stations are assigned to an paging group. So in the diagram, you can see that particular amount of number of base stations forms a page group 1 or page group 2 or page group 3. And and to maintain the location information, a mobile WiMAX network is divided into several paging areas or paging groups. And on detecting that it has moved, the mobile station has moved